Welcome to the Discover Mathematics series. In this video, I'm going to look at how people can discover the rules for the addition of polynomials for themselves using algebra tiles. This is from a set of store-bought algebra tiles. There's 6 different tiles. The smallest one has a length of 1 and a width of 1, so the area is going to be 1. And this one is red, so we're going to call this the -1, just like we did in the integer, when we used the integer chips. Okay, this next tile has a width of 1 and a length of x. So we're going to call this is x by 1, so this area is going to be x. And this has a width of 1 and a length of x, but it's red, so it's going to be called a -x. And this next tile has the same length as x and the width as x. So since it's x by x, this gives us x squared. So we're actually looking at the area, and this is a length of x and a width of x, but since it's red, this is going to be a -x squared tile. Okay, so we're going to be using the algebra tiles as an area model to demonstrate different polynomials. Okay, let's practice building a few models using the algebra tiles. Okay, the first problem that I have here is 3x squared plus 2x plus 1. So I need 3 of the x squared tiles, and the blue is the positive side. I don't want them to touch because I want to be able to see each different tile. And then I have 3 of the x squared tiles, 2 of the x tiles, and 1 by itself. So this is a model that shows 3x squared plus 2x plus 1. This is it. I can't simplify it. I can't do anything else with it. It's just what it is. Okay, for this next example, I have x minus 4. So here's an x, and then here's my 4, and I can't take 4 away from this x. So all I can do is, instead of subtracting, I can change this to x plus a -4, and what that does is it changes these from the +4 to -4. And the reason why I want to have it as addition instead of subtraction is because it's going to allow me to use the commutative property, in other words, to change the order of the add-ins as I work. So for this next example, I have x squared plus 2. So I'm going to write, here's my x squared, and here are my 2 units, my 2 ones, and that's it. I cannot combine them together. I can't do anything else with them. That's it. Okay, so we're just done with that. So what we should see at this point is we can only we can't add anything together because they're different. So we're going to look now at what happens when some of the terms are the same. Okay, now let's look at this example where we have 2 quantities set off by parentheses that are going to be added together. And we're going to build this. I'm going to see what happens. The first one, we have x squared plus 2x plus 1, and then we're going to add to it the second term, which is 2x squared. I'm going to put it below just because there's more room. So I have 2x squared plus an x plus 3. And then what we see is that we have some shapes that are the same, or terms that are the same. So if we put those together, kind of group them together, we can see that we have 3 of the x squared terms, put those together, 3 of the x's, and 4 of the other, the ones by itself. So this gives us 3x squared plus 3x plus 4. And when students use the manipulatives, they can't help but combine the like terms because it makes sense. They see it visually. And that's what we want, is for the algebra to make sense. Okay, let's look at the next example. We have x minus 4, which I'm going to build that as x, and when we had the minus 4, I'm going to change that right away to plus a negative. And the reason for that is because it's going to allow me to move them around. So now I have plus a negative. So now my problem is x plus negative 4 plus x squared plus x plus 4. And here, again, what makes sense is to put our like terms together, the ones that are the same shape. So here I'm going to have my x squared by itself, because nothing goes with it. My x goes with the x. And then here I have 4. I have the negative 4, and here's my positive 4. So this gives me a 0 pair, another 0 pair, a third 0 pair, and 4 0 pair. So I don't have anything left over. So my final answer here is going to be x squared plus 2x. And my plus negative 4 and my positive 4 gave me 0 pairs, which gave me a total of 0. Okay. When we look at the next problem, we have x squared plus 2. And here I have x squared plus 3x plus 1. So when I go to simplify this, then I'm going to put the ones that kind of go together. So I'll have 2x squared, the 3x, and the 2 plus 1 will give me 3. So I have x squared, 2x squared, plus 3x plus 3. So what I see, if I'm looking at what patterns do I notice, that I'm going to be combining the like terms. The things that are alike go together and we just add them. And that's what we'll notice. There's additional, you can make additional practice problems to continue, but that's all that we need to see at this point, is when we go to add our like terms, when we go to add, we combine our like terms. And that's how the algebra tiles are very powerful, because they won't make mistakes that they might otherwise make without the algebra tiles. It clarifies the addition process for them. Thank you.